Hello and welcome. Thank you very much for attending this meeting of CompTIA's Association of IT Professionals. My name is Steve Flowers and I serve as Vice President of the North Central Florida chapter of AITP. CompTIA is the leading global not-for-profit association for technology professionals, students, educators, and technology leaders. You may know CompTIA as the premier organization that pioneered a revolutionary IT certification, A+. This certification was not tied to a particular manufacturer, but was vendor neutral. The concept took off, and today CompTIA offers 4 IT certification series that test different knowledge standards from entry-level to expert. With more than 2,000 members, 3,000 academic and training partners, and tens of thousands of registered users spanning the entire information, communications, and technology industry, CompTIA has become a leading voice for the technology ecosystem. We focus our initiatives that support the success of businesses across the full IT channel, from the largest vendors on one end to smaller businesses providing IT hardware, software, and services on the other, as well as the ICT professionals that make our industry run. Simply stated, the industry's innovation and growth depends on you and hundreds of thousands of others just like you. We're here to help. Besides fostering and enabling IT certification, our mission is to be a voice and an advocate for the technology industry and to attract and enrich professionals through industry insight, networking, and education. Our vision is to be the go-to resource for individuals who seek to start, grow, restart, and advance their careers. We seek to fill the pipeline with the next generation of talent by supporting the largest, most diverse, innovative, and skilled workforce. As advocates for the technology industry, we also aspire to drive economic growth and benefit society. Our goal is to narrow the technology skills and confidence gap by encouraging people to enter the industry and by providing career-boosting tools and resources for the savvy IT pro. AITP traces its roots to 1951 and was formerly called the Data Processing Management Association, or DPMA. In 1971, the North Central Florida chapter of AITP was founded and is based in Gainesville, Florida. In 2016, CompTIA, seeing the need for a way to bring together IT pros, students, educators, and industry leaders, acquired AITP. We are leveraging the well-established leadership, organization, and infrastructure that is based on personal interaction at the local chapter level in more than 20 states around the country. Local chapters like this one are dedicated to the core values of ethics and professionalism in IT. We give back to our community by hosting presentations related to technology and business management. We also host socials and organize and promote networking events. We provide hands-on training, conduct tours of area tech facilities, and foster education. We encourage you to consider joining AITP if you desire to build your professional network, strengthen your technical knowledge and soft skills, develop a personal career path, and keep current on technology and business trends. Become a part of a large, growing, diverse, and talented group of CompTIA AITP members. We thank you again for investing your time and resources to join with us today. We hope you enjoy the experience. And now, let's introduce our special guests and begin the presentation. And welcome to this meeting of CompTIA's Association of IT Professionals. I'm Stephen Flowers, Vice President of North Central Florida chapter of AITP. I want to thank you for attending this presentation, which will focus on demystifying blockchain, a new technology that emerged with the introduction of cryptocurrencies. Blockchain has been the subject of thousands of news stories, and the use cases are boundless and the intrigue immense. Well, what exactly is blockchain? You're about to find out. But first, I'd like to thank Don Pizzette, co-founder and CIO of IT Pro TV. His company has graciously made this facility available to us, and we greatly appreciate his support. Among those in our audience tonight are several members of AITP, including Don, Mr. Michael Lucas, our immediate past president, web and social media director, secretary, and Mr. David Williams, our treasurer. Mark McDowell, our president, was unable to attend and sends his regrets. None of this would be possible without those gentlemen's significant and dedicated contributions to this chapter's success. This meeting is being streamed live on our chapter's Facebook page and will be available for review later on YouTube. And now let's find out more about our speakers. Mr. Dunkan Kabinu is a successful serial entrepreneur. He's the CEO and co-founder of Gainesville Dev Academy, a coding school started in 2015, and also helped co-found Gainesville Business Incubator Starter Space. Mr. Kabinu studied computer engineering at the University of Florida, spent 17 years working for the state of Florida, developing and managing enterprise database applications for state programs to protect and enhance Florida's multi-billion-dollar agriculture industry. Mr. Kabinu is passionate about entrepreneurship. He's been an avid entrepreneur since a young age, starting his first business while in college, and currently serves on the boards of the Gainesville Area Chamber of Commerce Technology Council, the Chamber of Commerce Human Capital Foundation, the Institute for Work Innovation, the Gainesville Area Innovation Network, now called Startup GNV, and the editorial board of Advantage Publishing. Our second speaker tonight is Dr. Mirek Sopek, who holds a PhD in theoretical chemistry and experience in both science and business. Dr. Sopek founded MakoLab in Poland in 1989, and after he led the company through a successful IPO in 2007, MakoLab expanded across the globe, opening offices in Paris, London, and Gainesville, Florida. MakoLab offers digital transformation services for a variety of industries. Dr. Sopek loves Gainesville. He first came here in 1996 to work with Hypercube, a company making molecular modeling software. In 2014, he co-created Chemical Semantics. And later on, Dr. Sopek opened MakoLab USA and is now doing business as LEI Info, the primary source of identification services for legal entities. Dr. Sopek focuses on the intersection between technologies, semantic web, blockchain, and quantum computing. He recently proposed the concept of an entirely new kind of blockchain called graph chain and is now applying it to the identification services of LEI Info. Ladies and gentlemen, please help me welcome our speakers.
Thank you, Stephen, and thank you, Dawn and IT Pro for hosting us on here. It's a pleasure to join you guys and kind of demystify blockchain, as he said. One thing that I found is that this topic is highly relevant because we see a lot of use cases that you see reported about blockchain, but what most people end up asking is, well, what is blockchain? And actually, I have an article in a local magazine called Business in Greater Gainesville, and there's an article in there this month that actually talks about blockchain, so you can always pick that up. Stephen just talked about who I am. Again, Duncan with Gainesville Dev Academy. It's a local boot camp. Teaches folks how to become software developers, both in web and mobile development. It's a 12-week program, and my contact information is available as you see on your screen right now. So let's get to it. What is blockchain? So the definition of blockchain is it's essentially a decentralized, distributed, and incorruptible database. Most of us would think of it as a digital ledger, and I'll explain that maintains a list of records. Each record is called a block, and each block contains the history of every block that came before it across many computers, or what's otherwise known as nodes, as you would hear. Most consider blockchain to be a ledger, a digital ledger, so to speak, much like an accounting system. The only difference, and we'll get into this, is the fact that it helps avoid what's known as the double entry problem that is usually brought on by the human intervention. Just to give you a perspective about blockchain and how old blockchain is, today, believe it or not, blockchain is 3,455 days old. As you can see on there, you see that the web is actually 10,000 days old, and so on and so forth, as you see with newspapers, radio, and television, which basically gives you an idea of how new blockchain is and how quickly it's actually grown as we talk about this. So we all commonly use cryptocurrency and blockchain together as if they are one and the same, but I want you to understand that they actually are not, right? Cryptocurrency first appeared in 2008 in a white paper that was printed by a person or persons with the pseudonym by the name of Satoshi Nakamoto. Basically, Nakamoto detailed an innovative peer-to-peer electronic cash system called Bitcoin that enabled online payments to be transferred directly without an intermediary. Currently, current platform is that you would typically take your money to a bank or write a check. That check goes through a bank system. The bank system sends it to the next person that you're paying to. And in this particular instance of this innovation was being able to directly pay one another without having anybody in between. The technology that makes this all possible is what we're talking about today is blockchain. Although commonly associated with cryptocurrency, blockchain technology has many other applications which you'll get to find out later on. You may say blockchain is to Bitcoin as the internet is to email, if that helps you understand the framework. And a great example of evolution and broader application of blockchain beyond currency is the development of what's known as Ethereum, a public blockchain for peer-to-peer contracts. And that too will be discussed later on. We'll get into that a little bit. So how exactly does it work? Looking at this model here, essentially you would have a person that is creating a transaction or wanting to send you money, maybe, or pay you for something. When that happens, that record is actually stored and distributed along in a node or in the network. And in that network, what happens is that information is validated and made that it's make sure that it's accurate, because essentially what we're working is a trustless system that basically has an algorithm to make sure that all transactions are legitimate. And that ends up being validated and through a process known as mining with miners, and we can talk about that in a little bit. And each block ends up building a transaction record, which is called a blockchain, in order to validate all the transactions that happen and keeping a current record. So essentially what happens, as the term says, cryptocurrency, there's an element of cryptography, where cryptography is the ability to encrypt or put a secret behind something. And so what they have is what's known as a cryptographic hash function that helps to secure your data so that it's incorruptible, as we mentioned. A cryptographic hash function is a function which takes an input or message and returns a fixed size alphanumeric string. This string is what's known as a hash value, or sometimes called a message digest or a digital footprint, a digest or checksum. Most of us know as checksums. One critical characteristic of a secure cryptographic hash function, it's one way or is immutable. Once you create it, there's no way to go back out of it. So if I put a hash value on something, you cannot reverse it to figure out what the original context of it was. So the output is virtually impossible or mathematically and computationally improbable to determine what the input was using a hash function. Cryptographic hash functions are also considered to be collision resistant. A collision is when a hash function produces the same output for more than one input, and that's not possible. Hashing is what's used extensively to run blockchains. Blockchain uses what's known as SHA-256, which is an acronym for Secure Hashing Algorithm 256. It generates a 64 character hash value, and we will see that in a demonstration here shortly. A typical block in a blockchain will contain several values in it. One is a block number or a timestamp. It will also contain what's known as a nonce value, which is essentially a random number. And then it also contains a record of some data, and then a hash data of the previous block. So every transaction in a blockchain is digitally signed by using this hash value, which takes all those things that I just mentioned, combines them, and creates a hash of that. A digital signature is essentially intended to solve the problem of tampering and impersonation in digital communications. Digital signatures are based on what's known as a public key cryptography. And to create a digital signature, what you'd have is signing software, such as an email program, which creates a one-way hash of the electronic data to be signed. Using a public key algorithm, one can generate two keys that are mathematically linked. One's a public key and the other's a private key. The private key is used to encrypt the hash, and then the encrypted hash, along with the other information, is the digital signature. The signer's public key is used to decrypt the hash. I guess analogy I could use is a convenience store that has a safe. Typically, they usually say whoever's working does not have keys to the safe. Typically, the system manager will have one key, and the manager will have another key, and you can't. And so one would be a private key if you want to think about it, and the other is a private key, and you need both keys in order to unlock it. It's the same case with where in public and private keys in this case. In blockchain, a valid hash would always start with 4 zeros, which you'll see later in a demo. And these 4 zeros are what determines the validity of that signature, as I'll show you shortly, and also give an explanation as to why the 4 zeros are significant to a blockchain. So this brings us to what's known as Merkle trees. Merkle trees are essentially a hash tree. Again, going back to what we said is a block. A blockchain consists of blocks that are combined together, where you have a block that has the value of a previous block, and this essentially creates what's known as a hash tree. And Merkle trees, which is the other name, are used in distributed and peer-to-peer systems for essentially data verification. Merkle trees are very fundamental to blockchain technology. Merkle tree summarizes all transactions in a block by producing a digital footprint of the entire set of transactions. Thereby, it enables a user to verify whether or not a transaction is included in a block. It's a tree where every leaf node is labeled with the hash of a data block, and every non-leaf node is labeled with the cryptographic hash of the labels of its child nodes. So hash trees can be used to verify any kind of data stored, handled, and transferred in and between computers. Once again, a block is essentially just a file containing a record of transaction data. A block represents the present and contains information about its past and the future. Each block contains records of some or all recent transactions and a reference to the block that preceded it. A completed block, and I say completed here, and I define that, is a permanent record of transactions in the past, and the new transactions are recorded in the current one. A mathematical problem is linked with each block, which we will demonstrate. Miners, as you've probably heard through cryptocurrency, people that generate coins, constantly processing and recording transactions as part of a process of competing in a type of race. The race is to complete a current block in order to win Bitcoins. New blocks cannot be submitted to a network without the correct answer. The process of mining is essentially the process of competing to be the next to find the answer that solves the current block. the linking of these blocks leads to what we call blockchain. Now, because any entity, individual, or party can submit information to the blockchain, it is necessary for the distributed operators of the blockchain to evaluate and agree on all blocks before they're permanently incorporated into the blockchain. So we cannot be sure of the author's trustworthiness. It is vital that all new information must be reviewed and confirmed before being accepted. This is what you hear the term consensus in cryptography and blockchain is what we're doing. And there are four methods of finding consensus in a blockchain. This is when we get to agree as nodes and computer operators whether the data that you're providing as part of a block to join a blockchain is valid and should be included. And there are four methods of finding consensus in a blockchain. There is Byzantine fault tolerance, proof of work, proof of stake, and delegated proof of stake. The most popular one that we are most familiar with is proof of work. Proof of work was also an innovation of Nakamoto to introduce distributed trustless consensus. Proof of work is requirement that expensive computations that we call mining can be performed in order to facilitate the transactions on the blockchain. The way it works is that all miners compete to find a number that when added to the block of transactions causes the block to hash to a code with certain rare properties. And we'll see an example shortly. Whenever a new block is mined, that miner gets rewarded with some currency. It could either be a block reward, transaction fees, or a combination of those, and thus incentivizing to keep mining. And this is how miners essentially make money by mining with the computers. So in proof of work, other nodes or computers verify the validity of the block by checking that the hash of the data of the block is less than a preset number. So let's look at an example real quick. Switch here. So we talked about hash values, and what I wanted to show you, this is part of cryptography, is that every piece of data generates a hash value that is 64 characters, as you see labeled down here. And I'll show you an example. If, for example, I put my name, Duncan, you will notice as I type that, this hash value changes. This data that we put on here, you can have any amount of data. It could be several paragraphs long, and it will always create a 64-character hash. You'll notice that if I change this and put a 1 after my name, that the hash completely changes. So how does this work with the block? Let's see that. So in a block, you will have, like I said, a block number or a timestamp. You will have a nonce, which is just some random number, and then you have your data, and then you have your hash value. So typically in a block, like we said, you'd have transactions. So for example, I want to store data that says Peter paid Bill $10. I can actually put that in here. Peter paid Bill $10. And Jane, I think it says Jane paid Peter $100. You'll notice that, again, the hash value is always going to be 64 characters no matter how much data we put into it. What you'll notice is that screen actually went from green to red because this is essentially not signed. Remember I said that in blockchain, a hash value is considered signed when it starts with 4 zeros. So here's the mathematical computation that a computer does, which is try and figure out how to get 4 zeros right here, which typically means changing the value of the nonce. And you could sit there and do this manually all day long until you find the right value, but that could take you forever. A computer can do about 4 million hash values per minute, I believe, if not less than that. But here's what miners do. You'll have a computer and you can tell it, go ahead and mine that and solve the problem And what you'll notice is now it's green, it has a new nonce value, and this hash value now starts with 4 zeros, which means that this block is now signed digitally and is valid. Of course, this is still verified by all the other nodes to make sure that it's acceptable so that it can be added to a chain. So let's get to a chain. What is a blockchain? This represents a blockchain, which is several blocks, obviously. And each one of them can hold its own value. You'll notice that in a block, if everything is signed, in this particular instance for visual purposes, every one of these blocks is green. If I should decide to change the value of this and add some information, well, that block suddenly went red, means that it is not digitally signed, and it's probably not valid because the assumption is somebody messed with the blockchain. And this is where that idea of double entries in digital ledgers cannot happen, because this will immediately flag every node that there's something wrong with it, especially when you're trying to do a consensus on it. And so you'll notice that every transaction going backwards from here would end up all being red, which means it invalidated a whole bunch and it would never be accepted. But you could essentially mine this particular block and it became valid, but then you'd have to go to the next block and keep doing this over and over. And as you can imagine, if you have every transaction that's ever happened in the lifetime of blockchain, this could take you forever. And so that typically would never happen. So that is essentially a quick demo of how blockchain works and how the computation is. Now, for every one of these, as I stated, every transaction, there's essentially, when we think about cryptocurrency, Bitcoin and all that, there's fees associated with this, because clearly as a miner, it costs you money for the energy. And so for every transaction or every action that you do that computes to a right signature and is accepted by consensus into their blockchain, you get rewarded for the transaction fees that were associated with this, as well as for your consumption. So it could be very profitable or lucrative, but it is also very highly expensive from an energy perspective, because your computers are computing a lot of information. All right, so back to this. So as I said, essentially blockchain is in essence just nothing but a database that features distributed, tamper-proof operation, and typically use a public ledger or timestamp for transactions. And like I said, it's not strictly related just to currency. It can be used for other applications. And with that, I'm actually going to turn to my colleague, Mirek, and he will actually go into some further detail about other application uses and other stuff and how you can get involved with cryptocurrency.
Okay, thank you. Thank you, Duncan. Thank you, Steve. Thank you, everybody, for having me here today. I'm going to tell you a little bit about different blockchain platforms that are available today and some of use cases. And I will also tell you in the end of my presentation when not to blockchain, because there is a lot of hype, as we know, about blockchain. So it's also important to understand when actually we shouldn't use this amazing technology. Okay, I usually start my presentation with a picture that, in my opinion, best illustrates what blockchain is. It's data carved in stones. Oh, sorry. Basically, what I say about that at that moment is that blockchain is the first technology on the world where the data cannot be changed safely. Okay, they can be changed, of course, but this change can be quickly discovered, and there is no way to really cheat in data when the data cannot be changed for some reasons. Okay, if we handle payment data, identification data, and so on and so forth. So that's very, very good metaphor, like a data card in stone. Let's go now for a little bit of bigger perspective on blockchain and discuss what are different classifications, what kinds of blockchains we have today. So first and foremost, Bitcoin and some other blockchains that I will tell you about are public blockchains. So that means that literally everybody, anyone can join and participate in the network. And that's the nature of Bitcoin as a currency. It must be like that because everybody is free to pay and to receive funds. So these are called public blockchains. They are secured, but the security comes through this proof of work that Duncan explained and other mechanisms that make them immutable. Okay? And where we still have this data carved in stone paradigm. However, for our industry, for enterprises, the much more important kind of blockchains are called private blockchains or permissioned blockchains. They usually run on networks that are permissioned. And basically what is a fundamental distinction is that we need invitation to participate in that kind of blockchain. And this invitation can be validated by network operator or by set of rules that we have for joining the network. So private blockchains allow implementation of blockchain technology for banks, for enterprises, for a variety of businesses, and resolve problems that are typical to the current existing or legacy databases that we had so far. There is also an interesting part of the whole classification called consortium blockchains, which are partially private. Basically, the idea is that we have trusted set of nodes that can validate the blockchain, that they can run these consensus mechanisms that Duncan explained, and the other users can be literally everybody. Okay? So everybody can read that kind of consortium blockchain and interact with data. But the validation and writing to the blockchain is reserved to specific people who are allowed, who are approved to do that. Okay, so the most important public blockchain, of course, is Bitcoin. And I'm not going to go because Duncan beautifully explained that. What it is, I will tell you a little bit more about Ethereum. And as Bitcoin is distributed transaction platform for financial transactions, then Ethereum is distributed computing platform. Okay, so that's a fundamental difference between Bitcoin and Ethereum. And this name, distributed computing platform, tells you something mysterious. It actually tells us that Ethereum is a kind of computer. So the whole blockchain called Ethereum is like one single computer. Okay, that's extremely interesting concept. There are some other public blockchains that I should mention. Hashgraph, EOS, NEM, Tezos. Some of them are controversial. Some of them may be reading last Wired magazine about Tezos. Extremely interesting article about that. But I would like you to come back to the explanation again about Ethereum so that we understand it. So this diagram shows again this fundamental feature of Bitcoin, which is the database of transactions. Now, Ethereum is database of smart contracts, which basically are computer codes and data that are generated and consumed by these contracts. So like Bitcoin transactions, financial transactions, then Ethereum transacts code. And now imagine what is the philosophical difference here. Because it's code, it means that we can do everything. Literally anything we wanted, which we can code into the language that is on Ethereum, can be part of the transaction, can create the global computer. And one of the best intro to Ethereum was given by Dr. Gavin Wood, who is part of Ethereum. I really recommend to go to this link that I copied here, because it shows literally how amazing idea was created with the invention of Ethereum. Okay, so that's public blockchains. Now, private permission blockchains. There is a lot of concepts, a lot of software packages. I selected only a few of them. And I'm going to tell you a little bit about one of them because it's almost impossible even to go into details. Hyperledger is this one that I selected. So in the next few slides, I will tell you a little bit more about that. I should mention 3 other extremely important private blockchains. R3 Corda. R3, first and foremost, is a consortium of banks and big financial institutions that come up together, invested money into the building of the private blockchain that could be used among banks to facilitate transactions and financial payments. That's what R3 Corda is. And the software called Corda is one of the most prestigious editions or instances of blockchains. Just a note, everything on blockchain, including these platforms, are open source. So anybody can go and interact with software installed, play, and so on and so forth. Ripple. Sometimes with Ripple, there is a lot of controversy. Some people say Ripple is not blockchain, but anyway, I don't want to go into details. It's a kind of specific blockchain that helps bank in payment processing, in digital asset exchanges, and a lot of corporate exchange like bonds and derivatives. So it's extremely important platform today. What is interesting in Ripple is that to finance their operation, they actually launched cryptocurrency called Ripples or XRP. And if you go to any exchange today, you can see that Ripples are very important. They are highly traded and worth a lot of money. So Ripple is certainly a very important platform. And Quorum is actually enterprise version of Ethereum. It is supported and maintained by JP Morgan, do not need to say who they are, and also open source. And so if you want kind of the enterprise level or enterprise version of Ethereum that will run only in your domain, you can go and take Ethereum. Okay, as I promised, Hyperledger. In my opinion, Hyperledger platform, if you like, it's a big platform, is one of the most advanced blockchain system ever invented. Even if the blockchain is short, as we remember, no longer than 4,000 something days, it's still an incredible achievement. Hyperledger is a part of Linux Foundation. So this famous Linux Foundation that was bringing Linux to the world now decided to somehow take care about the development of blockchain and apply the same quality rules. That's why this is so good. And I will be telling next slides about 2 of them, which in my opinion are more important than others. It's Fabric and Indy, but I need to tell you a little bit about these others. So Hyperledger Burrow is permission blockchain with smart contracts application engine. It's basically another version of Ethereum, okay? Private or permissioned Ethereum. Of course, the code in Burrow, contributed by Monax, is completely independent from Ethereum, but it proves that we can follow the protocol Ethereum and build another software. So it's an extremely interesting platform. And if anyone wanted to use Ethereum-like software inside a corporation or inside consortium among different groups of institutions, Burrow is certainly a choice. Hyperledger Iroha comes from Japan. It was contributed by a company called Soramitsu. And basically it's a general purpose permission blockchain, which is quite easy to deploy, quite easy to maintain, and has extremely nice applications in KYC, know your customer, know your client schemes or projects. Very good, of very high quality, and became part of Hyperledger, even though it's a little bit different from others, both from the origin and also from the underlying architecture. Sawtooth is very interesting blockchain platform because of being done by Intel. And what that means, as maybe you know, since few years, Intel started to include a cryptographic element into Intel chips. Okay, so we have part of the hardware that is designed to make a better cryptography. And Hyperledger Sawtooth is exploiting using this feature to provide even more security. So some of the institutions are already using Sawtooth because of these elements of additional hardware-based securitization in this platform. Okay, so Fabric, okay, these two left frameworks. Hyperledger Fabric was created by IBM. With all the power of the IBM, all the quality, there is another company behind that as well, and a lot of developers in the full open source community. Nonetheless, the quality comes basically from the IBM design. What distinguishes Fabric and what makes it extremely elastic, so to speak, platform is a pluggable consensus protocol. So basically, we are not faced with one protocol. We can change them. We can use many of them. One of the most interesting protocols that I found in Fabric is actually the simplest one. It's called CFT, Crash Fault Tolerant. Basically, CFT is like a replication mechanism. It's not a true Byzantine or proof of work or whatever consensus protocol. It's a very simple crash fault tolerant protocol. You can use Fabric with this protocol to safely replicate your database across different nodes in your organization and provide crash fault tolerance. Simple like that, of the highest possible quality. So that's very interesting, you know, elastic kind of, or modularity in this software. Smart contracts in Hyperledger Fabric called chain codes can be written in almost any language. They can be plugged into the ledger, and you can use Java, Go, JavaScript, and whatever other languages that people decided to make compatible with Fabric. So it's very interesting. Another thing, Fabric can function as a certificate authority. So it can actually create digital signatures on its own, and it can actually be used to identify members, assign them, keys, and so on and so forth. So it's extremely interesting applications can come from that. So basically, it's a highly modular architecture in Fabric, and this gives also ability to run it on multiple different databases. So with Fabric, depending on your existing infrastructure, your legacy architectures in IT, you can use different databases. Okay, who uses Hyperledger? I can't, of course, list them all, only a few that I think are very important in this picture. So DTCC is a famous company here in the US. It's Depository Trust and Clearing Corporation. They are responsible for settlement, financial settlements in financial markets. And they use Fabric, perhaps experimentally so far, and nonetheless, they are a very important user of Hyperledger Fabric. Fujitsu, General Electric, Hitachi, State Street Bank, of course IBM, because of obvious things, and SAP are among the prestigious users of Hyperledger Fabric. Okay, next framework that I selected to tell you a little bit more is Indy. Why Indy is so important is that it's a first blockchain that focuses on digital identification. So Indy is not very much platform for financial transactions or for smart contracts. It's platform for creating a future digital ID for us as people and for companies, for legal entities. That will be also clear why I'm interested very much in Indy later. But what is almost demonic in this platform is that using this platform, we as users can have total control over our digital identity. So unlike our digital signatures that are issued by some certificate authorities, okay, which of course they claim, okay, you have your private key and so on and so forth. Nonetheless, we know that we cannot really govern that fully, okay? So they have a lot of shortcomings. Indy promises something very big. And there is a foundation behind. I will tell you about that foundation, which is building a future of digital identification system based on Indy. Its consensus protocol is called Plenum. Doesn't matter what it is. It's Byzantine fault tolerant. It's very fast protocol. What is interesting from the programming perspective to some of you guys, it's written in Python. So such amazing platform and written in Python, which is also making it very easy to use, very easy to modify, and absolutely fantastic platform for development. One of the most interesting features of Indy that I found in the platform is zero knowledge proofs. It's really another demonic thing in this concept. So what you can do, you can prove certain claims that you make. You can prove certain facts, certain truths, that they are true, but you not need to reveal them. So it's like a mechanism that you can claim, okay, this statement is true. You do not need to show what is the content of this statement. Nonetheless, the whole algorithm is such that there is no possibility that you are cheating if you claim that this is true. It's called zero knowledge. So there is no transfer of knowledge of the content of Ethereum, but there is a transfer of certainty that it is true and validated. Okay, so it's very good for a lot of privacy issues where we can claim that we did something. Okay, I paid my taxes, and they ask, okay, how much did you pay? And I say, it's not your business, but I claim that I pay my taxes. Okay, I don't go into details of that kind of scheme, but anyway, that's possible from the mathematical perspective. Very interesting applications. Notable users of Indy: Sovereign Foundation that I mentioned before, and Evernym, the company that makes products on Indy for identification, of course. Desert Financial Credit Union, DigiCert, which is the private key signatures authority, its own, IBM, T-Labs, which is T-Mobile R&D arm, among the most important users. Okay, so if you look at this quality and this scope and size of the software, you may think that really there must exist a lot of applications of blockchain. And perhaps these slides that I have are a little bit hypey. They say, okay, blockchain can disrupt everything. I will put a kind of cold shower later on that claim. Nonetheless, let me tell you that indeed we see clearly that these industries that I list here are really to change dramatically because of blockchain. And banking and fintech is changing on our eyes, so we know that there's no question about that. Cybersecurity will certainly change because blockchain is much more secure than standard encryption. Okay, this network security and the security in the distributed system is another layer that didn't exist before. Supply chain management can be disrupted because using blockchain, we can absolutely prove every single element of our supply chain. We do not need to quarrel with our suppliers because everything is on blockchain and it is immutable. Forecasting, okay, so forecasting for sport events or for anything can also be in such a way that nobody can claim that it was not done. Networking and IoT, Internet of Things, why this will also be disrupted. If you imagine billions of IoT devices, it's certain that there is no single central hub or entity that could manage that, even in some subdomains of a whole space. So blockchain, which is in nature totally distributed, and there is no central hub, is perhaps one of the most interesting platforms for management of multiplicity, hundreds, thousands, millions of IoT devices, just because of the nature of the distribution here. Private transport and ride sharing, very beautiful company we know, Uber, okay? But see, Uber is one central authority. They run the system. They run applications, payment system. This is still a company of the old age. Why old age? Because they are centralized. This is like Amazon of books. They are these, Airbnb and others. And I don't have a name here. There are already startups that are doing exactly this. They provide the platforms for sharing cars on blockchain. So that's absolutely going on right now. Cloud storage, there is a company called storej.io that already offers that kind of platforms. There is a company called Golem, and this Golem is like a gigantic computer that it's like a, using computers in a set-at-home manner, but on the blockchain where you can be paid for your contribution into the calculations. So there is a lot of things. Let me name voting. If we put elections on blockchain, nobody will have any doubt about the results, okay? Because everything will be auditable. We can go to every single vote, and count that, count again, and we can't change the results. So I do not need to claim to tell you how important it is, okay? And the same about online music, where the possibility of connecting you as listener to your artist in the direct way without intermediary is also going on. Finally, crowdfunding, that's already what happens. These TISOs that I mentioned before, they raised in 2017 something like 700 or 800 million through crowdfunding using ICOs. So this is a reality. That's already disrupted crowdfunding completely. Fintech space it has absolutely amazing number of use cases. And in one of the consulting works that we were doing recently in Europe for some central bank in one of the European countries, we have listed a number of use cases and described how we can use blockchain for every single on this list. Of course, I'm not going to go into all of them. I will only tell you a little bit about one case, which is commercial property and casualty insurance, where basically we can use blockchain to make a fraud detection and fraud prevention, claim processing, client onboarding. Onboarding is easier because we have already data on the blockchain. So there is a lot of interesting solutions when we apply a blockchain to commercial property and casualty insurance. We even went further into designing on a very high level, of course, structure using Hyperledger Fabric, how to use Fabric to handle that kind of the use case. And basically, it runs in such a way that every insurer has the node, and also payment providers have nodes, okay? And a very specific agent called Oracle that decides, it's a software that analyzes, basically AI software that analyzes claims. And what basically is the advantage is that payment can come much faster than the traditional way in the insurance. Okay, so that are use cases that I wanted to show you. And as I said, it's a little bit hypey. So now this is called shower, okay? And it goes, okay. So when to blockchain and when not to blockchain, okay? This part, I would like now to say that, of course, blockchain technology is not a panacea for everything, okay? And a beautiful article by amazing specialist, which is actually a lawyer, Dr. Adrian McCullough, and he wrote this fantastic article, Blockchain Technology is not a commercial panacea to every problem. And I can't, of course, relate all the article. I selected the most important part, which actually can be used by everybody, by you guys, to discover if your project that you may have fits well into the blockchain paradigm or not. This model was first developed by law researchers at Law Features Center and Griffith University. And basically it's called FITS, F-I-T-S. And this model helps you to decide, to consider blockchain as a technology when, A, you have high possibility of fraud. So if the environment that you are running your project is potentially threatened by fraudulent behavior of some agents, this is where the blockchain can reduce risk. So fraud is a place which we can combat with, it's something that we combat with blockchain. Then I stands for intermediaries. If we have many or such intermediaries that are intermediaries, but they do not provide value, okay? This is not saying that every intermediary is bad, okay? There are a lot of good intermediaries. Nonetheless, if we discover that they don't provide the value, we can reduce their number or eliminate them altogether. So basically when we have a system or business where there's a lot of agents, okay, we can discover if they really provide value. If not, then blockchain can help. Then if you have a high need for high throughput of business transactions, then blockchain can speed them up. Like, for example, typical wire transfer between different banks takes sometimes days, okay? Not to speak about the cross-border transfers. They are very, very long, and settlement of the financial instruments on stock markets is sometimes going into days. So blockchain can really help in that. But there is a little caveat here. Many people would say that, well, blockchain is not very fast. Like Bitcoin is slow. And many people actually complain. And there was a lot of studies telling that blockchain is too slow for real-life applications. And to that criticism, I would like to tell you that there are some interesting new inventions going on that can actually create blockchains that are much faster than Visa or SWIFT networks, going into hundreds of thousands of transactions per second. And one very experimental thing is called Red Belly blockchain, comes from Australia. There's an inventive genius who created that concept. There is Hashgraph that made a launch in March this year, very big launch in New York for their extremely interesting blockchain using a double gossip protocol. And there is algorithm that I think comes from some university. I am not sure. Maybe it's even Stanford. Well, don't remember very well. It's Algorand, which is a very, very fast consensus protocol that actually could be used on public blockchains like Bitcoin to speed up, dramatically speed up, by orders of magnitude, the consensus that we can do. So throughput is not a problem. It's actually, when we need throughput, that's a kind of a signal that we may use blockchain. And finally, when we have need for extremely stable data, that's this mantra of data carved in stone. That's like a signal that that's probably where we need blockchain to go. And I have a very funny algorithmic approach that you can run against your project. I borrowed that from Marcus Sabadello from Austrian Danube Tech presentation, which is like an algorithm to ask ourselves. Of course, it's a little bit primitive, maybe, but actually it gives you a lot of understanding when not to go too quick for a blockchain. So if you don't need a database at all, forget about blockchain. Doesn't make any sense. If you don't need database, then why blockchain, okay? Then if agents or users are not writing simultaneously to this blockchain, if you don't have them writing at the same time in big number, then you don't need blockchain. Okay, there's a single user or a single very well-defined number of users, and we can protect database with standard methods. Why using blockchain? Okay, now, if we have answered yes to these questions, then the question is, do the agents or users trust each other? And if they don't trust, we still need to ask ourselves, is there one agent, okay, in whom all others would trust? If we have such an agent, we again do not need blockchain. We can use this agent facility to provide trust. And only when we have agents which do not trust each other, and if there is no one, even in trustful scenario, that we could trust, then we surely need a blockchain. Okay, so this is like a algorithmic approach to tell you that don't go too fast. Okay, in some sense. Then, if you come for these and you are sure that you want blockchain, I really have a few advices. Okay, so that depends, of course, on the question: do you have developers, which are usually well paid today because of these ICOs and everything? So blockchain development is quite expensive, I can tell you, everywhere. Here in the US, in Europe, in my original country, everywhere, it's quite expensive. So if you have them, I certainly advise you to use Hyperledger, one of frameworks, for quality. I don't think there is anything better than Hyperledger. You can have one of these platforms. There is another set of applications from measurement of throughput, of efficiency and everything that makes Hyperledger the platform of choice. But if you don't have developers, or you can't have them in numbers enough for your project, then you can use something that recently started to show up on the stage, which is called blockchain as service. A note here: you need to be quite careful because the nature of blockchain is distribution. So if you have someone who claims, "Oh, I have a blockchain in clouds," then the good question is, really, is it blockchain? Okay, because if it's in the cloud domain of Microsoft, for example, or Amazon or IBM, then the question is, okay, where are the nodes and who control them? Okay, so there is a lot of questions and investigation to be made. Nonetheless, clearly you can use blockchain as service to start your projects, at least to test your ideas, to develop applications that later could potentially be replaced by the real development. You can use Microsoft on Azure. They have absolutely excellent implementation of R3, Corda, Ethereum, and Hyperledger, of course. I think it's Fabric, if I remember well. Amazon uses actually Sawtooth, this famous thing which uses hardware cryptography already. They have also Corda and some other platforms that are, for example, famous for healthcare applications. It's called PokiDoc, which is quite interesting thing for healthcare applications. IBM, for obvious things, they promote Hyperledger, so their cloud allows you to develop applications for Hyperledger Fabric. SAP, famous company for ERP system, has something called Leonardo that is also based on Hyperledger. So basically, you can go to the cloud and use them as services. Or some other smaller players like Uledger and Peer Ledger that are allowing you to develop applications on the blockchain. Okay, finally, I will tell you shortly what kind of projects on blockchain I was leading and what MakoLab, both in Europe and here in the US, is doing in the space. So even though we try to be in R&D part of blockchain, we still have extremely practical applications. So the first application of blockchain that we are now implementing as we speak is for a system called LEI. LEI's legal entity identifiers are universal, global, trustworthy identification for businesses, for legal entities. LEIs were invented by G20 and Financial Stability Board after 2008 crisis, which one of the reasons of a crisis was that we couldn't identify banks, okay, properly. So that was the system that was created. We have 1.2 million companies already registered across the globe, okay, so it's a huge distributed system of registers, companies that register these LEIs, and also companies that provide data. So the mission of LEI Info that I started in March this year in Gainesville, Florida, okay, is to literally enable users to register new LEIs. So you can go to this portal and register yourself if you have a company. And also you can search for other institutions. And basically it serves KYC purposes. You can verify that the bank you potentially can take credit from or buying some securities is already existing and realistic. Okay, so that's what LEI basically is. But I'm going only to tell you about our blockchain idea. So basically the current, sorry, switch is too fast. Current LEI system, because it was done in a traditional way and also in the kind of European way, it's very centralized with a foundation called Glyph on top of that, okay, and LOUs, local operating units, that have their own databases that register companies in their jurisdictions and so on and so forth. And it's pretty standard. And what we know is that people who are behind LEI, particularly in Glyph Foundation, are very, very bright people. So they know already that blockchain is the solution for the future. So we are creating right now a model, a system, using our LEI.info company as the first node and working with other players to demonstrate that this blockchain is of real value. Of course, while we do that, we hope that when we are done, when we are good, Glyph will come to us, okay, or run a solicitation or something, and we will get good business to create a global system based on blockchain. We are using Indy on that, and we are using something that we developed in our R&D department, which is called GraphChain. Let's go to this GraphChain. And what GraphChain is that we realize that if we have a structured data, so we have data about these banks, okay? These data are XMLs, JSONs, okay? Different kinds of structured data. To have them on blockchain was complicated because blockchain is a pretty standard, typically primitive data structure, okay? Even Ethereum, you need to pack your data structures into this Solidity language, and so that was pretty tricky. You do that, and you can search. Or you can search, but you search slowly, okay, on a big blockchain. So we said that rather than trying to add graphs or structured data to blockchain, we try to add blockchain capacity to graph or standard database. We other way around. And that was the birth of the concept of graph chain. Initially, we went into a specific graph data model. I don't want to go into details. It's called RDF graph data model. We have very good publication on that run by ACM. Everybody can go and find that and read about this concept. And the only thing that I would like to show you, perhaps, is the animation, how this thing works. So what you can see here is a graph. We compute hash of this graph, as Dan can explain. But you see, this is graph. So it's a completely interesting data structure. It's not a flat block, okay? Then we have the concept of the graph chain ledger, which is like a metagraph that contains information about these data graphs. That's where we have that across the whole network, okay? In this simulation showed on all 4 nodes. And we have a consensus mechanism that creates graphs in other locations. And then we have another graph being built and another and another and another. What is the end game here is that every single node in our network runs this whole structured database, which can be searched, queried, okay, and explored with traditional way, as we use that for years on graph databases. And still, it's absolutely protected by blockchain mechanisms. That's what we are right now implementing for LEI. Okay, that's exactly this thing. We have also a little bit of the blockchain consulting. Okay, in this consulting, we create this LEI concept. We advise companies on the technical aspects of blockchains. One of the projects that we are right now in is a tender run by Central Bank of the smallest European country, Lithuania, which is absolutely great on innovation and development. And we hope to win a place in this thing, maybe, I don't know. Then we also recently started to work a little bit of the extremely interesting concept, which is called quantum blockchain. And that will be the end of my talk, literally. I would like to tell you something perhaps strange in this moment. So blockchain is young, okay? It's 3,000 days. And already we know that there exists existential threat to blockchain. Okay, so with this beauty of cryptography and this immutability and everything comes a huge, huge danger. What it is? It started in 2015 when the National Security Agency announced that it's moving to quantum-resistant cryptographic systems with their operations. Okay, so they realized that when quantum computer is finally built, then existing algorithms are in danger. And of course, blockchain uses these algorithms, so there is a huge danger. So is it realistic today? Not yet. But I had a guy from Cisco, and I asked him, what Cisco is doing for blockchain? Why we don't see Cisco on blockchain? And he tells me, well, because we are sure that when a quantum computer comes, all blockchains are dead. Okay, I don't know how influential this guy was. Maybe Cisco is doing something, but that was the kind of answer that I got from a real person. Okay. So there are some remedies. First and foremost, there is an interesting startup, QRL, Quantum Resistant Ledger. They raised a lot of money through ICO and delivered absolutely amazing algorithms that are quantum resistant. And I also, with a group of students in China, working is too early, but I'm very much exploring this concept of quantum-enhanced logic-based blockchains. Basically, what it is that if blockchains are threatened by quantum computers, then we can use quantum computers to protect blockchain, okay? And there are some flavors of quantum computers that can be used today to protect blockchain, or to create quantum blockchains that are resistant to quantum computers, obviously. So that's everything, okay? And thank you for your attention.
Okay, so we're going to open the floor to any questions you guys have. I have a microphone that I'm going to bring around to you. So if you have a question, just kind of raise your hand and I'll bring the mic to you and we can find out a little more about our presentation.
Always wearing the black hat. Is there a way the blockchain could be misused? In other words, maybe to hide from prosecution or to sort of, fake something that looks like it should be real but isn't? If you understand my question. In other words, how could the technology be abused?
Oh, well, frankly speaking, the technology is already abused. Okay? And this abuse comes from these fraudulent ICOs. There are many of them. Okay? Sometimes we don't have even intention to make a fraud. We have a result or outcome of that. So maybe you remember this case of DAO on Ethereum. Okay, there are hackers who stolen like 1/3 of money put by investors into DAO or distributed organizations. Okay, built on Ethereum. So it's already abused. If I understand your question correctly, you ask if somebody can create blockchain to do some harm. Perhaps. If you read Wired, that I recommend, last edition of Wired about Tezos, there is potentially the kind of accusation that Tezos is maybe like that. I am far from that. Okay, I'm waiting for July 1st when Tezos is to open their platform, and I hope that they will deliver because it will be huge harm. It was the largest ICO in the history, as I said, 700 or 800 million, and the article called Blockchain Love Story, Blockchain Horror Story, is actually telling that there is something behind that. Okay, so it's very hard to judge, but perhaps it's possible, as these cases show.
Yeah, I believe there's a case where pretty much anything can be abused if it exists. There was a consulting group, I don't know the name, I can't recall the name, but pretty much go through Bitcoin's blockchain to see the data and the transactions that actually exist in there, and found that there was pornographic data actually stored in blockchain. So yeah, there's always possibility of abuse. The good part is when you have an open system, it's obviously makes it available for people to audit and be able to see what's out there. That's the beauty of having that, is that, but abuse is always possible.
Transparency of the system,
right? Correct.
Guarantees that you can at least persecute it.
You had a long list of companies that were either looking or you said using blockchain. Are there any of them actually using it in production, the business type of applications in production right now yet?
Yep. I just learned about absolutely extremely realistic in full production application in Italy between different banks. Specificity of doing business in Italy, not just in Italy, but perhaps in many countries, is the need for factoring. This service. I mean, you issue the invoice and you are not paid by your client. Okay, so what you do to make your cash flow in check, you go to the bank and you give them this invoice, okay, and they pay you, and then they go after the client for payment. Now, what you could do and what happened and happens is that you take this invoice, you go to bank A, you tell them, okay, this is the invoice, I want to factor it, okay, and then you take the copy of this invoice, you go to bank B, and both are paying you. And these cases, of course, they are persecuted, and mechanisms and data and millions of things to help that from happening, but that was going on. So the consortium of Italian banks extended the contract and commissioned an international company in Europe called GFT to build the system. They built that on Corda and delivered that. And I listened to a lecture recently of one of the persons from this environment. They have that in production already. So this helps, as we speak, in avoidance of the fraudulent double registering of invoices among different banks. It's hard process because there is multiplicity of banks, and this communication between them was too slow to really, protect that. Simple like that.
All right. We got another question in the back?
I had read recently that Kodak had introduced or was planning on introducing a system to, I believe they were trying to verify attribution of digital photographs. So I presume the creator was always, credited. Have you heard anything about that, or?
I didn't. I must tell you that I heard about the other cases where the intellectual rights to art creations were to be protected by blockchains, but I didn't hear about this Kodak thing, so I'm sorry I can't tell you details.
I was wondering if this means that cryptocurrencies are going to supplant dollars, rubles, the euro. I mean, is real money, quote unquote, going away? What's going to happen to people who don't know much about blockchain but know they're concerned about their money? What's going to happen to the value of the money? How is this technology going to change things?
I guess, this is purely my opinion, but pretty much everything that we're dealing with is highly speculative. But stored value is something we're seeing historically has changed from one thing to the other. So we started off where we would barter by giving, I have something that you want and so on and so forth. But at some point it was like, how do I know mine's worth as much as yours? And so we went to money. And so I believe that the first occurrence of cryptocurrency is purely a beta, if I may say that, about Bitcoin. And as blockchain and other technologies improve, especially given, like Mirek talked about, how the slowness of the network for transactions, as that improves, I think digital currency would definitely be a way to go. I don't know about the people that are not familiar with it, because when I look at countries like third world countries, they actually far more progressive than we are, especially given the fact that they don't have infrastructure to build towers and networks and poles and all this other stuff. So they are very, very innovative with the little they have, and it's helped them get past certain elements like and increase economy from taking folks from being poor and being able to transact without using any money. If you look at, even though it's not blockchain related, but certain parts of East Africa, they use what's known as a M-Pesa, and people are not using cash anymore over there. And it's used by almost 80% of the country. So I just see digital currency as, in my estimation, as what we will be doing one day.
Yeah. I think there will be amalgamate of the fiat money, as we call dollars, euros, and other currencies, and digital currencies over the next couple of years. However, to answer your question, I think I need to tell you something that I'm not libertarian. Okay, so I don't think that these currencies will change the whole structure of everything, and governments will not create money, at their own and facilitate their political agendas by creation of money and budget deficit and all these things that we know that are quite bad, of course, right? But I don't think that we are very quick to replace these kind of fiat money by digital currencies that have a different mechanisms. However, one of the most influential economists and philosophers that I admire very much is Hayek, okay, Austrian economist Hayek. And Hayek, in the end of his life, wrote absolutely amazing article, which was not about Bitcoin or blockchain, because it didn't exist, of course, in 1950s. That was even pre-Euro era, okay? But he wrote in abstract about the situation of something like local currencies that can be used in local communities for exchange of goods and actually avoid inflation, okay? And this very article, if you just write in Google, Hayek, cryptocurrency, blah, 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 something like that, you will find it, okay? It's a free book about that. It literally shows path for the use of local currencies, read that, digital currencies today, in specific environments. And I know about cities, one city in UK, that issued their own currency that is used internally between their stores and things and avoids something. I don't even remember what, maybe not taxes, you know, but so I think that there will be amalgamate of these things, not total replacement, but slowly we'll go to the situations where we will get more power into people's hands, basically, through these currencies that are not very much controllable by governments.
Since this requires the mining, blockchain requires mining, will there be a limitation in the world processing power as blockchain is more adopted? I mean, I guess mining can be infinite, but is there a thought of how much processing can we actually do?
First of all, I realized that in the current format, that blockchains and in terms of mining, there is a finite time that you will have mined all the coins possible mathematically. That period, we don't know when that is. It's all based on that cryptography. It gets harder and harder to get to mine a block, and that's part of that hashing value that I talked about with the 4 zeros. Those zeros that start in the beginning are actually intended to create the mathematical difficulty of mining, so that it's actually throttled so that you can't mine too fast, and also prevents fraud and that kind of stuff. In terms of computing power, I think what we've seen is that people like NVIDIA and the rest of them have been able to keep up with the demand for mining units. But the biggest concern, I think, at this point is the amount of energy that it takes to produce or to mine, because it's getting harder and harder to do it. And that's where the biggest concern is. I believe currently Iceland, which has some of the larger mining facilities, are essentially using more power than the entire country uses just for mining purposes, and it's just going to get more and more expensive. So I don't think that. And well, you may have opinion on this.
Yeah, my opinion is that first and foremost, we will see soon new protocols that will change this equation. And I mentioned 3 of them. And of course, it may be again another hype, but go to this hash graph, okay, this Hedera hash graph initiative. They claim that their consensus protocol doesn't cost that kind of energy, even if it grows exponentially. Okay, so that's first. Second, I recently listened to an absolutely amazing lecture by, I'm sorry, forgotten the name, famous Japanese professor. He's from Stanford. He's probably on a path to get Nobel in physics. Okay, and it's very easy to find. You find it in Math We Trust. In Math We Trust, and he claims the following: that making consensus on a large scale, you know, is making order. It's like life, okay? You make order. You order all databases across thousands of nodes on Bitcoin. It must cost energy, okay? Whatever energy it is. So he compares cryptocurrency to life, okay? Life is making order, going against entropy in physics, right? So he claims that that cannot be done without cost. And it is his answer to the claim that, oh, Bitcoin is so bad because they, you know, use that amount of energy and so on and so forth. He claims, okay, that's bad, but that's a cost of making order, okay? So that's perhaps a kind of answer, a little bit philosophical or physical to you, that it's unavoidable in some sense. However, as I said in the beginning, I think that we face a new kind of consensus mechanisms that would change these. What I would love, I can tell you, I would love a completely different solution. I would love a situation in which this mining could do good work, okay? It would not compute these zeros and nonces like Duncan showed, and the random numbers, you know, and all these things, but, for example, would simulate proteins, would find drugs, okay? And if we could have someone who invent how to make positive calculations in science in such a way that this scientific computation is proof of work, okay, then we do good and create money. I don't know any solution to that yet, okay? But that's my hope for the future.
All right, ladies and gentlemen, we are running quite a bit long on the presentation, so this is going to be our last question. If you have more questions, I encourage you to ask them after the presentation's concluded. Oh, okay. All right. So we're going to go ahead and wrap up here. Stephen, I'm going to turn the floor over to you, and I want to do just a big thank you to our presenters. It was a great talk. I really appreciate you spending time with us.
Duncan, Mirek, I want to thank you very, very much for elucidating blockchain. I still kick myself a lot because about 8-9 years ago I read about it when Bitcoin was $9. And so I must be a blockhead. But a couple of announcements. If you're interested in AITP and want to see about the benefits that can accrue to you as a member, we urge you to go to AITP.org and learn all about it. We'd love to have you join as actual members. Also, our next meeting is going to be on Tuesday, July 24th. Our expected presenter is in the room with us, David Nessel, who's going to be talking about entrepreneurship at the local level and what resources are available. So thank you for attending. We appreciate it, and good evening. Thank you.
Thank you. Thank you.